Hello everyone, welcome to my YouTube channel. In this tutorial, I will be sharing with you on how to solve problems on relations, functions, domain and range, ways of presenting relations, a one-to-one function, how to use vertical line test to identify a function, and finally, how to use a horizontal line test to identify a one-to-one function. But before we continue, I want to encourage you to subscribe to this channel, like the video, share the link with your friends, and also please click on the notification button. Thank you very much for your support. All right, let's get started. Just before we go into solving problems, please take note of the following key points. Number one, a relation. A relation is simply a set of ordered pairs. As you can see in the example below, 1 and 2 is a pair. 2 and 4 is a pair. 3 and 6 is a pair. 4 and 8 is a pair. And 5 and 10 is a pair. So a set of these ordered pair is what we call a relation. Next is the domain. A domain is the first number of each ordered pair. As you can see in the above example, 1 is the first number of this pair, 2 is the first number of this pair, 3 is the first number of this pair, 4 is the first number of this pair, and 5 is the first number of this pair. So a set of these first number is what we call the domain. It is also called the input value or the independent variable x. Next is the range. The range is the set of the second number of each ordered pair. As you can see in the above example, 2 is the second number of this pair. 4 is the second number of this pair. 6 is the second number of this pair. 8 is the second number of this pair. And 10 is the second number of this pair. So a set of this second number is what we call the range. It is also referred to as the output value or the dependent variable y. Next is the function. A function is a relation in which each possible input value leads to exactly one output value. A function is a relation in which each possible input value leads to exactly one output value. The output is then a function of the input, or the output is dependent on the input. And the set of the input value is what we call the domain, while the set of the output value is called the range. In this example we have below, you can see that 1 is an input with an output value of 2, and 2 in the second pair is an input value with an output value of just 4. 3 is an input value with an output value of just 6. 4 is an input value with an output value of just 8. And 5 is an input value with an output value of just 10. Therefore, this relation is a perfect example of a function because each input value has exactly one output value. Okay, I hope this makes some sense. Now, let's quickly look at the different ways of presenting relations and functions. Number one is by mapping. Number 2 is by tables. Number 3 is by graphical method. Number 4 is by function notation. And finally, number 5, by ordered pairs. Now, using the mapping method, we have two relations that we need to examine. Now, let's look at them carefully. The first relation, we have P being an input value, has a single output value of X. And Q being an input value has a single output value of Y. And R being an input value has a single output value of Z. Therefore, this relation can be considered as a function. Also, let's look at the second relation. This is 4 being an input value, has an output value of 0 and 1. Now, a situation where an input value has more than one output value, such a relation cannot be a function. Now, let's look at number 2 using the table method. We have two examples, and the first one, we have 1 being an input value, has a single output value of 8, and 2 being an input value, has a single output value of 6, 3 has an output of 7, 4 has an output of 6, and 5 has a single output of 8. Therefore, this relation can be considered a function. Also, we have another example. 2 is an input value with an output value of 2. 8 is an input value with an output value of 6. 2 is an input value with an output value of 1. And 10 is an input value with an output value of -6. Now, if you look at this table carefully, you discover that 2 appeared twice. So 2 being an input value has two different output values. In the first case, 2 has an output value of 2, and in the second case, 2 has an output value of 1. Therefore, this relation is not a function because 2 has more than one output value. Let's now look at number 3, the graphical method. The graphical method is used to represent a relation, and for us to test if the relation is a function, we use the vertical line. As you can see, the vertical line that is drawn through the graph. If the vertical line cut through the graph at just one point, as you can see here, at one point, then such a relation is considered a function. But if the vertical line cut through the graph at two different points or more than one point, as you can see, this vertical line cut through this graph at two different points. Therefore, this relation is not a function. All right, let's look at number 4, the function notation. F of x is equals to 2x plus 1. So if we plug in any value of x into this function, there will be exactly one output value. Therefore, f of x equal to x plus 1 is a function. Let's look at the second example. G of x is equal to the absolute value of 3x. Because an absolute value has both negative and positive value, it means that if you plug in any value of x into this function, it will lead to two different outputs. Therefore, g of x equals to the absolute value of 3x is not a function. Number 5, using the ordered pairs. You can see in the first example, -2 is an input value with an output value of 6. 0 is an input value with a single output value of 10. 1 is an input value with an output value of 12. 3 has an output value of 16. Therefore, this relation is considered a function. Let's look at the second example. 3 is an input value with an output value of 5. -4 is an input value with an output value of 6. -2 is an input value with an output value of 4. And 3 is an input value with an output value of 2. So if you look carefully, you discover that 3 has two different output value. 3 in the first case has 5 as the output value, and 3 in the second case has 2 as the output value. Therefore, this relation is not a function. I hope this makes some sense. All right, now we can go into solving problems. All right, now let's quickly look at the following questions. The question says, for the following exercises, determine whether the relation represents y as a function of x. Let's take question 8. 5x plus 2y is equal to 10. Now, the first thing we're going to do is to write this equation in terms of y, or make y the subject of this formula. Now, to do that, we are going to subtract 5x from both sides. And when we do that, this becomes 5y is equals to 10 minus 5x. At this point, we can divide both sides by 2. Divide each term by 2, rather. And if we divide each term by 2, 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. And 10 divided by 2 is 5. So, this is going to give us y is equal to 5 minus 5 over 2x. So at this point, we can write this equation using the function notation. And that is going to change y to f of x equal to 5 minus 5 over 2x. Now, at this point, you discover that if we plug in any input into this relation, we are going to have just one answer as the output. So for every input plugged into this function, there will be just one answer as the output. Let's take, for example, if we plug in 0, this is going to be 5 minus 5 over 2 times 0. Now, this is equal to 5 minus 0, which is equals to 5. So you see, the input 0 has given us 5, a single answer. So for every input value that is plugged into this relation, it gives out just one answer as the output. Therefore, this relation is a function. I hope this makes some sense. All right, let's move on to the next one. Question 9. Y is equal to x squared. This equation is already written in terms of y. So the first thing we are going to do is to simply write it using the function notation. And that is going to be f of x equal to x squared. Now, if we plug any input value into this relation, it's going to lead to exactly one output. Let's take, for example, if we plug in 1, that will be equals to 1 squared. And 1 squared is equals to 1. So 1 is an input, and that led to an output of 1. Let's also plug in 2. This will be equals to 2 squared, and 2 squared is equals to 4. For this input value of 2, that gave us 4, just one output value. So you can see for every input value that will be plugged into this relation, it will lead to exactly one output value. Therefore, this relation is a function. I hope this is clear to you. Question 10. We have x is equal to y squared. We can also write this as y squared is equal to x. Now, let's take the square root of both sides, and that's going to be y is equal to plus or minus the square root of x. At this point, we can simply change this equation or write this equation using the function notation, and that will be f of x equal to plus or minus the square root of x. So for every input value that will be plugged into this relation, that's going to lead to two different output value of both positive and negative number. Let's take, for example, f of 4. This will be plus or minus 4, and that is equals to plus or minus 2. Therefore, 4 being an input value has led to plus 2 and negative 2. Therefore, this relation is not a function. I hope this makes some sense. Question 11. 3x squared plus y is equal to 14. So the first thing we are going to do is to write this equation in terms of y. And to do that, we are going to subtract 3x squared from both sides. So that's going to give us y is equal to 14 minus 3x squared. So at this point, we can change y to the function notation by writing y as f of x equal to 14 minus 3x squared. So now, if you look at this relation carefully, you discover that for every input plugged into this relation will lead to exactly one output. Let's plug in 1, for example. F of 1 is equal to 14 minus 3 times 1 squared. And this will be equals to 14 minus 1 squared is 1, and 1 times 3 is 3. So 14 minus 3, and that's going to give you 11. So 1 being an input lead to exactly one output value of 11. So for every input that will be plugged into this relation, it will lead to exactly one output. Therefore, this relation is a function. I hope this makes some sense. Okay, let's move on to the next one. Question 12. We have 2x plus y squared is equals to 6. So the first thing we are going to do now is to write this equation in terms of y, or simply make y the subject of the formula. And to do that, we are going to subtract 2x from both sides. So that's going to be y squared is equal to 6 minus 2x. Next is to take the square root of both sides. And when you do that, y will be equals to plus or minus the square root of 6 minus 2x. So at this point, we can simply write this equation using the function notation. F of x equal to plus or minus the square root of 6 minus 2x. So now for every input value that will be plugged into this function, that is going to lead to two different output value because of the plus and minus sign that you have here. One of the answer will be positive while the other will be negative. Therefore, this function, this relation is not a function. I hope this makes some sense. 13. Y is equals to negative 2x squared plus 40x. This equation is already written in terms of y, so we can simply write it again using the function notation. That is f of x is equal to negative 2x squared plus 40x. Good. So now let's look at it carefully. If we plug in any of the input value, that is going to lead to exactly one output value. So let's take, for example, f of 1 equal to negative 2, 1 squared, 40 times 1. 1 squared is 1, and 1 times negative 2 is negative 2, plus 1 times 40 is 40, and this is going to be 38. So for every input value, you are going to have exactly one output value. Therefore, this relation is a function. I hope this is clear to you. All right, let's move on to the next one. All right, the question says, for the following exercises, use the vertical line test to determine which graphs show relations that are functions. Now, let's look at the first question, question 40. All we have to do is to draw a straight line, a vertical line through this graph. You can see it cut through the graph at one point, test another point. Just keep testing. It cut through the graph at one point, cut through the graph at one point, cut through the graph at one point. Therefore, this relation is a function. All right, let's look at question 41. If you draw a vertical line through this, it cut through at two different points, this point and this point. If you draw it through another point, you can see it cut through the graph at two different points. This is not a function. Let's look at the next one. If you draw a straight line, it cut through at one point, it cut through at one point, it cut through at one point, but at this point here and at this point, if you draw a straight line, it's going to cut through at two different points. Okay, and this point, at this point here, x is 0. So when the input value is 0, the output value is both negative infinity and positive infinity. Therefore, this relation is not a function. I hope this makes some sense. All right, let's look at the next one. Question 43, draw a straight line, a vertical line. It cut through at one point, it cut through at one point, cut through at one point, cut through at one point. This is a function because the vertical line cut through the graph at just one point. Okay, let's look at question 44. Draw a vertical line. You can see it cut through these are two different points. At two different points. This is not a function. Let's look at question 45. If you draw a vertical line through this at one point, it cut through at one point, it cut through at one point. This is a function. I hope this is clear to you. All right, that is it for this question. Let's quickly move on to the next one. All right, let's quickly look at this question. The question says, for the following exercises, determine whether the relation represents a function. These questions are given in ordered pairs. So let's look at question 60. We have negative 1 is an input value, and it has an output value of negative 1. And also we have negative 2 is an input value, with an output value of -2. Also, -3 is an input value with an output value of -3. So for every input value in this question, there is exactly one output value. Therefore, question 60 is a function. All right, let's look at question 61. 3 is an input value with an output value of 4. 4 is an input value with an output value of 5. 5 is an input value with an output value of 6. So for every input value, we have exactly one output value. Therefore, question 61 is also a function. Let's now look at question 62. 2 is an input value with an output value of 5. 7 is an input value with an output value of 11. 15 is an input value with an output value of 8. 7 is an input value with an output value of 9. So in this question, you discover that 7 appeared twice. 7 in the first case has an output value of 11, and 7 in the second case has an output value of 9. Therefore, this relation is not a function because 7, being an input value, has more than one output value. All right, I hope this makes some sense. Now, let's quickly move on to the next question. All right, the question says, for the following exercises, determine if the relation represented in the table form represents y as a function of x. So now let's look at question 63. 5 is an input value with an output value of 3. 10 is an input value with an output value of 8. 15 is an input value with an output value of 14. So for every input value in this table, we have exactly one output value. Therefore, question 63 is a function. Now let's look at question 64. 5 is an input value with an output value of 3. 10 is an input value with an output value of 8. 15 is an input value with an output value of 8. So you can also see that for every input value, we have exactly one output value. It doesn't really matter if two different input value, okay, have the same output value. As you can see, this is 8 and this is 8. So 10 being an input value has 8 as the output value, and 15 being an input value has 8. It doesn't really matter. As long as one input value has exactly one output value, it is a function. Question 64 is therefore a function. Let's look at question 63. Question 63, we have 5, an input value with an output value of 3, and 10, an input value, has an output value of 8. Also, 10, an input value, has an output value of 14. Because 10 being an input value has more than one output value, this question is therefore not a function. I hope this makes some sense. This question says, for the following exercises, use the function represented in table 14 below to evaluate f of 3 and also to solve f of x equal to 1. Now, f of 3, you can see that the input value here is 3. So all you have to do, go to the input value x and trace where you can find 3. You can see this is 3 and the output value is 53. So it means that f of 3 is equal to 53. So this is the answer to this question. And also solve for f of x is equals to 1. Now, this is the f of x. So now trace that to where you can find 1. And this is where you can find 1. And the input value is 2. It means that f of 2 is equals to 1. So this is the answer to this question. I hope this makes some sense. All right, let's quickly move on to the next one. All right, this question says, for the following exercises, evaluate the function are the values f of negative 2, f of negative 1, f of 0, f of 1, and f of 2. Okay, so now let's look at question 68. We have f of x equal to 4 minus 2x. So for f of negative 2, we have f of negative 2. This is equals to 4 minus 2 times negative 2. This will be 4. Negative 2 times negative 2 is plus 4. So this give us plus 4. And finally, this will be equals to 8. So this is the answer to this question. All right, let's look at the next one. F of negative 1. So f of negative 1 is equal to 4 minus 2 times negative 1. And this will be equals to 4. Negative 1 times negative 2 is plus 2. So this will be equals to 6. I hope this makes some sense. So now you can try f of 0, f of 1, and f of 2. You can practice for those three values. Okay, let's quickly take question 69. So question 69, we have f of x is equals to 8 minus 3x. So for f of negative 2, this will be equals to 8 minus 3 times negative 2. And this will be equals to negative 2 times negative 3 will give us positive 6. So this will be equals to 14. So this is the answer to this question. Okay, let's also solve for f of negative 1. So f of negative 1 is equals to 8 minus 3 negative 1. So negative 1 times 3 is going to give us positive 3. So this will be 8 plus 3. And finally, this will be equals to 11. I hope this makes some sense. All right, so you can solve for f of 0, f of 1, and f of 2. You can practice with those values. Finally, let's take question 70. Question 70, we have f of x equals to 8x squared, minus 7, minus 7x plus 3, So for f of negative 2, this will be equals to 8 negative 2 squared minus 7 times negative 2 plus 3. And so this will be 8 times 4 minus negative 2 times negative 7 will give us plus 14 plus 3, and 8 times 4 is 32. So we have 32 plus 14 plus 3. So if you add up these three numbers together, so this is going to give us 49. So this is 49. And so this is the final answer to this question. I hope this makes some sense. All right, let's also take for f of negative 1. So for f of negative 1, this will be equals to 8 negative 1 squared minus 7 times negative 1 plus 3. So this will be equals to negative 1 squared is 1, and 8 times 1 is 8. So we have 8, and negative 1 times negative 7 is plus 7 plus 3. So this will be equals to 18. So this is the final answer to this question. I hope this is clear to you. So now you can practice for f of 0, f of 1, and f of 2. I hope this makes some sense. So, all right, let's quickly move on to the next one. Now, this question says, what is the range of the following relation? To solve this problem, First, we need to identify the second number of each pair. As you can see, the second number of the first pair is 5. The second number of the second pair is 8. The second number of the third pair is 1. And the second number of the last pair is -1. Next, we need to write them as a set, starting from the smallest to the biggest. So now the smallest number of these is -1 and 1, 5 and 8. So if you look at the option carefully, the right option would be A. So this is the answer to this question. I hope this makes some sense. All right, let's move on to the next one. Now, this question says, determine which of the following are functions. Now, to solve this problem, we are going to use the vertical line test. And a vertical line has been drawn through the first graph, as you can see. And the vertical line cut through the graph at two different points, at this point and at this point. So when a vertical line cut through a graph at two different points, then such a graph is not a function. So number 1 is not a function. And number 2, a vertical line is also drawn through the graph and it cut through it at one point, as you can see over here. So this is a function. And number 3, the vertical line cut through the graph at two different points, as you can see at this point and at this point. Therefore, number 3 is not a function. And number 4, the vertical line cut through the graph at one point, as you can see over here. So this question, this graph is a function. So the graphs that are function in this question are number 2 and number 4. So the right option is B. I hope this makes some sense. All right, let's move on to the next one. Now, let's look at a one-to-one function. A one-to-one function is a function in which each output value corresponds to exactly one input value. Let's see from the following example. In this first example, we have two different tables of functions, and we shall be examining them one after the other. In the first table, the output value g of n has 6 at two different places, which means the output value 6 corresponds to two input value 2 and 4, which means this function is not a one-to-one function. In the second table, we see that the output value 1 corresponds to 2, 2 corresponds to 3, 9 corresponds to 6, and 13 corresponds to 8. So from these, you can see that each output value corresponds to exactly one input value in this table. Therefore, this function is a one-to-one function. I hope this makes some sense. In this second example, we have two mapping functions. And in the first case, you can see that 4, being an output value, corresponds to two input value 3 and 5. Therefore, this function is not a one-to-one function. And in the second case, we have P corresponding to X, Q corresponds to Y, and R corresponds to Z. Each output value corresponds to exactly one input value in this second case. Therefore, it is a one-to-one function. I hope this makes some sense. In this third example, we have two different graphs, and to determine if they are one-to-one function, we are going to use the horizontal line test. And if the line is drawn through them and it cut through the graph at two or more points, then such a graph or a function is not a one-to-one function. Now let's see. The horizontal line is drawn and it cut through this graph at this point, and also at this point, at three different points. That means this graph or the function is not a one-to-one function. Let's also test for the second graph. We have the horizontal line drawn and it cut through this graph at just one point over here, which means this graph or function is a one-to-one function. I hope this makes some sense. All right, this is all we have for today. So if you find this video useful, please don't forget to subscribe to this channel, like the video, share the link with your friends, and also click on the notification button. Thank you very much for your support. I'm looking forward to seeing you in our next video. Bye-bye.